Welcome to Slice 6. Now, you'll remember that we're talking about platelet tethering. So the next question that should be going through your mind is, well, what have you got on screen now? Okay, so what I want you to think of this as is as follows. So this stuff here at the bottom, that there, okay, that's the collagen. So then that stuff there, that is immobilized von Willebrand factor. So what we need to think of now is what's going to happen as a platelet comes with its glycoproteins, comes rolling along the inside of our vessel. Okay, so what's going to happen is something like this. We draw in like this. We'll say we'll have glycoprotein 1b. That's a bit rubbish actually. Make that a bit thicker. So yeah, we'll have glycoprotein 1b. There's the thing that's going to attach to the immobilized von Willebrand factor, and then we've got our platelet like this, and we've got glycoprotein 1b there, further around the platelet. So if you remember, I said the platelet's kind of like blue tack with Lego bricks attached to it. So remember that this platelet is rolling. So it just so happens that as I've drawn it, that there is the first platelet glycoprotein that has come into contact with the von Willebrand factor. So for all intents and purposes, you could equally imagine that the platelet has got glycoprotein 1b expressed all the way around it. And I've just so happens that I've picked that one. So, what's going to happen next? Well, what's going to happen next is that platelet is going to continue to roll forward. So, as it does, see if we can do it like this. As it continues to roll, I'm not going to be able to do that. I'm going to have to actually draw it. I'm going to have to go old school. So let's draw it as it continues to roll. So we'll leave that one there. Like this. And then what's going to happen is that platelet is going to continue to roll over, causing the other glycoprotein 1b's to come into contact with the other von Willebrand factors as it rolls over. So now, and again, if we wanted to, we could express further von Willebrand factor over it, like further glycoprotein 1b over it like that. So we end up in this situation where we've got our platelet and we've got this interaction of the glycoproteins, and specifically the glycoprotein 1b's, to the immobilized von Willebrand factor. Okay, So, just so I'm a little bit happier with myself, I'm just going to remove these and then redraw the platelet again. Okay. That. So there's our setup. Now, there's an issue with this. Okay. The issue is basically that this G1B to immobilize von Willebrand factor, this interaction to, let's just finish it to the subendothelium. So this is an interaction that we've got. We've got the glycoprotein 1B, immobilized von Willebrand factor, and the subendothelium. The issue that we've got is this isn't stable enough. Why? Well, I want to make sure I'm doing this correctly, and it's because this setup here has a very, what's called a quick dissociation rate. And what that means is that they can bind quickly, but they can also unbind as well quite quickly. So, how do we solve it? Well, the simple fact of the matter is that we solve it using other glycoproteins. If you remember that when we the previous slice, where we looked at this diagram, and we said that there's all sorts of different platelet glycoproteins that we have available. We've just been talking in detail about that, the glycoprotein von Willebrand factor interaction. But if you look, we've also got this. We've got glycoprotein 1A, 2A that can attach a platelet to the collagen itself, and we've also got two other glycoproteins that we haven't yet talked about. Well, we've talked about one of them. We've talked about this glycoprotein 2B3A, but what we also haven't said is that this glycoprotein 2B3A can also attach itself to von Willebrand factor. Now, the other thing, of course, about glycoprotein 2B3A, there it is there too, is that it is a little bit more robust than glycoprotein 1B. And what do I mean by that? Well, I mean that it can withstand higher shear stresses. Now, what we're talking about here is basically tethering a platelet down onto something which has got quite a high flow rate. Okay, so I'll just draw the flow in like that, a high flow rate. So what have we got? What have we done? So we had this guy attached first, then the platelet rolled over, and the other three they attached. That's what we've done. We talked about a load of other stuff. So let's just tidy this diagram up a little bit. Let's get rid of that. Dissociation rate. You now know that that's collagen. And you know what we're talking about here. Okay. So we'll leave in this flow like that, just to remind ourselves that we're talking about a high flow environment. What we do need is I need another bit of von Willebrand factor. So I can talk about it. Okay, like that, just pop that in there. So what's going to happen this platelet is going to start moving its Lego bricks around, and it's going to drop. I'm drawing in yellow. I have to start labeling stuff actually, don't I? So we've got. Let's put it over here. G1B. And then we've got this in a slightly darker orange. This is going to be G2B38. And that's what's good. That's the first thing that's going to happen, is the glycoprotein 2B3A is going to cause an interaction with von Willebrand factor. And then what we then find is that we get another glycoprotein. What colour should I do this? Green. This glycoprotein is going to bind directly to the collagen. And this is the last step. And this one is glycoprotein 6. Okay? So, first thing that happens, as we've already talked about, is glycoprotein 1B. That is going to bind to von Willebrand factor. So we're in a high flow environment, which means that we get indirect binding, and then glycoprotein 1B is going to be the first thing that steps up. Next thing, glycoprotein 2B3A is going to bind to von Willebrand factor. Actually, do you know what? I've done a dirty here. And I'm not going to edit this out, okay? Because that's the kind of guy I am. There's another step, and there's another glycoprotein that is going to bind before glycoprotein 6. We'll draw that in here. I'll draw it in purple. Here we go. Here he is. And that's glycoprotein 1A. That is going to bind to collagen. And then, finally, glycoprotein 6 is going to bind to collagen. So 4 steps. And that is going to secure our platelet in place. The key is that, and I'm going to write this down, it's the interaction of glycoprotein 6 and collagen. That is what causes the platelet to become active. Okay, so it's the glycoprotein 6 and collagen interaction that is going to cause final activation of platelets. So what does it mean when a platelet becomes active? Well, when a platelet becomes active, it's going to do a couple of different things. Number one, it's going to cause an increase in the calcium concentration inside the platelet, so actually in the cytosol, so increase concentration of calcium in the platelet cytosol. Number two, it's going to start rearranging the platelet's actin cytoskeleton. It's going to cause a rearrangement of the actin cytoskeleton. Number three, it's going to cause activation of an enzyme, type of enzyme called tyrosine kinases. And then number four, is going to cause further activation of glycoprotein 2B3A, which is about platelet to platelet binding. So the key is that circulating platelets, in other words inactive platelets, do have an expression of this 2B3A, okay, but it's got a fairly low affinity for von Willebrand factor, and it's got a fairly low affinity for fibrinogen. So yes, it is there and it is doing some stuff, but the platelet's got to be held in place for it to do so. Once that platelet becomes active, then all bets are off and everything starts to really to ramp up a gear. They're kicked up a notch, as you could say, I suppose. So what happens with this platelet activation is that it's going to result in something called, and it's something that we actually, if I was doing this in a lecture, I would probably have a slide on it. It's called platelet inside out signaling. And it's going to cause structural changes inside the platelet, and it's going to cause the platelets to start to change shape. But we'll deal with that in the next slice.